When I first started studying fire engineering, I was obsessed with the building materials. I'd look at concrete walls, steel beams, and fire doors, thinking if the walls are thick, the building is safe. But then, I analyzed a fire report from a modern office. The walls were perfect, the sprinklers were there, but the fire burned so hot that the steel beams twisted like spaghetti. I was stuck. I couldn't understand why a supposedly safe building had failed so catastrophically. If you're an engineering student, you might be making the same mistake. You look at the structure, but you ignore the contents. The real question isn't how strong is the building, but why does a small room full of plastic burn hotter than a large library full of books? Today, I am going to show you the one calculation that determines if a building stands or falls to fire. Load and why most students get it wrong. Everyone talks about fuel like wood, paper, and cloth, but they miss the most important part, energy density. Imagine two suitcases. Suitcase A is huge, filled with 50 kilograms of wet newspapers. Suitcase B is tiny, holding just 5 kilograms of petrol. Which one scares you more? Suitcase B, right? Why? Because it contains more stored energy waiting to get out. In fire engineering, we call this the calorific value. Most students see a warehouse full of wood and think, that's dangerous. Then they see a small server room with plastic cables and think, that's safe. Wrong. Plastic is basically solid petrol. It burns twice as hot and twice as fast as wood. That tiny room is a bomb waiting to go off. This is the hidden fuel trap. Let me show you the math. The only formula you need to remember today is total heat equals mass times calorific value. Let's compare to rooms. Room A is 100 kilograms of wood, which has a calorific value of about 4,500 kilocalories per kilogram. That's a total of 450. 0 kilocalories. Room B is just 50 kilograms of plastic chairs, computers, cables. But even if you get the math right, you can still fail if you miss this last step, where 90% of students lose marks. They calculate the total heat, but forget the room size. Think about it. If you release 500,000 kilocalories of heat in a giant football stadium, nobody notices. If you do it in a tiny elevator, it's a disaster. You must calculate the fire load density by dividing the total heat by the floor area. This number, the density, tells you if a building needs a 2-hour or a 4-hour fire rating. So, here's the lesson. Stop looking at the volume, start looking at the chemistry. Don't just count the boxes, ask what's inside them. Is it wood, or is it plastic? If you want to stop guessing and start engineering, master these calculations. And if you want to learn the practical side of safety, not just textbook theory, make sure you subscribe. We don't just solve the math, we save lives with it. Stay safe, check your calorific values, and I'll see you in the next one.